We've covered a fair amount of Animal Crossing's programming oversights on this channel before, but there are still quite a few more to discuss. So in this video, we'll return to a more technical side of Animal Crossing, as we uncover more coding bugs in the original game. As we go, I'll do my best to explain exactly how each bug works and show the programmatic solution on how to potentially fix them. That said, let's get started. Our first instance of broken code involves the growth of trees in the game, which actually has a pretty annoying bug associated with it. What if I told you that harmlessly planting a tree in 1 acre can actually kill another sapling in a different acre several screens away? See, the game has a specific system put in place that governs when trees are considered valid to grow. For example, planting a tree sapling too close to a building or planting 2 saplings too close together will cause them to wilt and die the next day. To handle this programmatically, the game checks the direct spaces around any planted sapling to see if they're empty. If they are empty, the tree grows normally, but if not, the tree wilts and dies. This is pretty simple on paper, and this code typically works fine, but there's a glaring bug with this check in the case that a tree is planted at the very bottom of an acre border. If you've played the original Animal Crossing, then you're surely familiar with the acre system, where the game actually pauses and shifts the camera every time you walk between acres. Due to the way this acre system is set up, the developers had to implement special code when checking around a sapling that is on the edge of an acre. For example, let's say you plant a sapling on the very bottom of acre B5. The game then checks around the sapling to see if it can grow, but since the area below the sapling is within an entirely new acre, the game needs to check this space in reference to that new acre rather than the current acre that the sapling is in. So the game should simply update the acre to C5 and check this space at the top since it's right below the sapling. But due to a bug in the code, the game actually checks if this space is clear all the way over in C2. This means if there's something like a building or another tree planted in the top section of acre C2, this will actually kill the sapling located in B5 despite being extremely far away. This occurs because of this code here. Internally, the game's acre system is essentially a 2D array of numbers, where the first number is acre Z and the second number is acre X. For example, in-game, acre A1 is mapped as 00, acre B4 is mapped as 13, acre E5 is mapped as 44, and so on. If we revisit this code, you can see that, when checking the bottom of a sapling at an acre border, this code incorrectly swaps to acre Z+1 as the first number and acre Z as the second. So again, let's say we're in acre B5, or internally, 14. If we plant a sapling at the bottom of this acre, the new acre to be checked is calculated as acre Z+1, acre Z. Again, since we're in acre B5 right now, our acre Z value is internally 1, so the new acre to be checked will equate to 1 + 1, 1, simplified to just 2, 1. In-game, 2, 1 equates to checking acre C2, and this is clearly unintentional. This bug is easily fixed by using the appropriate variable acre X as the second input rather than acre Z, which was the obvious intention. But, as it stands in the retail game, you can indeed accidentally remotely kill your saplings just by planting saplings in entirely different acres, which is a bit annoying, albeit humorous. Our next oversight is a quick one and has to do with the weather of the game. The original game cycles through clear weather, light rain, thunderstorms, snow, and blizzards. This is actually the only game in the series without cloudy weather, or clouds at all, since, well, you can't see the sky. Anyways, there is a special cherry blossom weather event used in early April, where you can witness Sakura leaves falling from the trees. Similar to rain and snow, there is supposed to be a lighter version of this cherry blossom weather set to play on April 5th through the 7th. However, internally, the game incorrectly references the light snow weather effect as the chance for this to occur. Since of course, it never snows in April, the effect of this is that the lighter cherry blossom weather never plays throughout the entire game. You can see this lighter variant by hacking the game's weather values, but you can also fix this issue entirely by looking at this piece of code and updating the light snow reference to correctly refer to the light cherry blossom weather. Next, let's take a look at a funny bug relating to bugs. Snails. Now, most bugs in this game have wings and the ability to fly. Yes, apparently even grasshoppers and mantises can fly in real life. One of the few critters that you can catch that cannot fly is a snail, which appears on flowers in the rain. Despite this, many people have noticed that releasing snails sometimes causes them to just up and fly away as if they had wings and were a normal bug. This is different from what normally happens, since releasing a snail typically just sets it loose on the ground. However, it seems catching a snail with a full inventory and releasing it immediately after catching one causes the game to use the incorrect release, resulting in the snail flying away. Other bugs that can't fly, such as the ant, do not have this problem and are always released on the ground no matter what. So this little oversight is actually exclusive to the snail. This glitch also only appears in the Japanese and North American versions of the game. There aren't too many differences in the Australian and European versions of Animal Crossing, but this snail flying away glitch was one of the things that was patched in those versions. Another funny oversight involves your town assessment on startup. In the original Animal Crossing, your town is assessed or rated based on the number of trees, weeds, flowers, and trash in each acre. Receiving a perfect town rating equates to having 9 to 18 trees per acre, no trash left anywhere except the dump, and 5 or less weeds per acre unless offset by flowers. How well your town is rated impacts things like critter spawn rates and the frequency at which special NPCs visit. This town rating calculation is reran every time you choose to check your town rating at the wishing well, but it is also executed on startup, which is where the coding bug is found. I mentioned that you cannot have any trash in your town without impacting your rating, with the exception of the confines of the dump. How this works is that the game checks your dump acre and basically checks the confines of these coordinates inside the actual dump. The issue is that when this calculation is ran on startup, the game uses the incorrect acre for the dump. Hilariously, the game uses the town that you see on the title screen when referencing where the dump is. And since the title screen towns are pulled from when the game was on the Nintendo 64, these towns don't actually have a dump at all. Since the game is checking for a dump acre that doesn't actually exist, the game incorrectly penalizes your town rating for having any trash placed in your own dump. This occurs because the town assessment check is ran too early when starting up, and fixing this involves some special code to correctly assess the dump acre in your town rather than the title screen. I should be clear, this bug only exists when starting up the game, and your town rating is correct if you check it manually at the wishing well. So to circumvent this bug entirely, just make sure to have no trash in your dump at all, or to always check your town rating at the wishing well. Moving on, I'd like to revisit some funny bugs that I've previously touched on, many of which are the result of typos or silly oversights. In the interest of not repeating myself too much, I'll rapid fire off some of the fixes here. One of the things I mentioned last time is that coconuts were intended to wash up on the island beach and are actually treated as seashells in the game's code. However, since the island's table of spawnable items is initiated with an incorrect size, coconuts can never be rolled when the game chooses an item to spawn on the island beach. The reason for this has to do with an oversight when copy-pasting code from the normal seashell spawning tables, so fixing this bug is as simple as updating the table size to appropriately accommodate the extra coconut object. I also previously brought up the funny oversight of Annie Cotty's e-reader card gifting you a bass fish rather than a base instrument. Fixing this is also pretty trivial, and you can simply update the item ID within the card's dot code to appropriately point to a base instrument. Similarly, Igloo campers in winter have a chance to reward you with a fully invalid dummy item. This is because the developers never removed this leftover item ID from the list of valid rewards that they can give you. Simply removing this item ID from the list and updating the size will fix this dummy item from being obtainable. But this dummy item is entirely harmless and kinda neat, so maybe we shouldn't fix this one. Next, I've mentioned many times how the developers constantly misremembered or misused their own random function throughout the game. For the unfamiliar, this random function in Animal Crossing rolls a number between 0 inclusive and the parameter exclusive. For instance, if the game calls the function random10, this function can only return integers between 0 and 9, since 10 is excluded as the game truncates downwards. This implementation is intentional, but the developers consistently use this function as if its parameter is an inclusive value. For example, Tortimer is supposed to gift you a random diary on New Year's Day, and the game uses this function to determine which diary to give you. The issue is that the game is trying to call this code to choose from a list of 16 diaries. This code is very puzzling since this essentially equates to just random 15, with this bitwise AND operation being entirely redundant. Again, since we're calling random 15 here, this function will return an integer between 0 and 14 since the parameter is always excluded. This means that the 16th diary, or the calligraphy pad, is impossible to be rolled, and Tortimer will never gift you it. Fixing this bug is as simple as just removing the -1 and the bitwise operation here, which increases the random parameter by 1 to make 15 a valid integer to be rolled. Another case of this is the bug responsible for it being impossible to obtain oranges through villager gifts if your town fruit is apples, cherries, or pears. I've talked about this before, but when talking to a villager, there's a chance they'll gift you a fruit that is different than your native fruit. This was done to make it possible to obtain different fruit trees even without multiplayer. Similar to the Diaries, the game has a list of fruits numbered from 0 to 4, and the game uses its random function to determine which fruit you're going to receive. Of course, since the game calls the function with 4 as the parameter, the only numbers that can be returned here are 0 to 3. This may make it seem like oranges are completely impossible to be gifted, but the game has a special check to add 1 to the return number if the number corresponds to your native fruit. That is, in the one case that your town's native fruit is peaches and the random function rolls a 3 to gift you a peach, the game will recognize that you already have peaches and will add 1 to the return value to instead gift you oranges. But in all other cases where your native fruit is apples, cherries, or pears, it is completely impossible to be gifted oranges. So how do we fix this? The naive answer would just be to update the random parameter to 5 instead of 4, so that every fruit has a possibility of being rolled. But remember, this code in particular adds 1 to the return value in the case that the rolled fruit is equal to your native fruit. Thus, if oranges were your native fruit and you happen to roll oranges, 1 would be added to the returned index here and you'd end up outside of this list. Since we're working in C here, we should account for this ourselves and code a solution to loop back to apples just for this edge case. A decently clever solution would be to use the modulo operator and mod 5 when returning this index, which will always cap the return value between 0 and 4, and if it ever goes beyond 4, it will loop back to 0, which is essentially what we want. However, this implementation still isn't perfect since it creates a bias towards one fruit. A better solution would be to just use a new list entirely that excludes your native fruit so you can randomize it with equal odds. For our next oversight, we have to talk about the lunisolar calendar system, which is a bit complicated. As you all know, Animal Crossing has in-game holidays that align with real-life holidays on their exact dates. Some of these holidays are always on the same date, such as Toy Day always falling on December 24th, or the fireworks show always falling on July 4th. A few holidays are a bit more complex, such as Labor Day occurring on the first Monday of September, or the Harvest Festival occurring on the fourth Thursday in November. However, far and away the most complex holiday calculation in the game is the Harvest Moon Festival. This holiday is supposed to align with the real-life viewing of the harvest moon. In the real world, the harvest moon is defined as the full moon that occurs closest to the autumn equinox. In the northern hemisphere, the autumn equinox can occur on September 22nd or the 23rd, and thus, a particular year's harvest moon can fall on a myriad of dates in September or October. It all depends on which date has a full moon closest to the equinox. Given this complexity and the wide range of dates, how the hell does Animal Crossing actually calculate this holiday to align with the real-life harvest moon? The answer is that, on top of Animal Crossing having a Gregorian calendar, which we're all familiar with, the game also internally has a lunisolar calendar calculation to keep track of the moon. The game uses this lunisolar calculation specifically for the Harvest Moon Festival, and its sole use in the entire game is to calculate which full moon date occurs closest to the autumn equinox. Anyways, I'm mentioning this here, so I guess it is pretty complicated because the developers did indeed screw up their calculations when using this lunisolar system. Given how complex the Harvest Moon date calculation is, the developers actually pre-calculated the dates of all Harvest Moon festivals up to the year 2030. However, the calculations they use are slightly incorrect. In lunar terms, the Harvest Moon Festival is supposed to occur on the 15th day of the 8th moon of the year. But how it ends up working in Animal Crossing is that the Harvest Moon Festival is occasionally calculated to be the 14th or 16th day of the 8th moon instead. This in turn converts to slightly incorrect Gregorian dates. Due to this, over half of all the Harvest Moon Festival dates are incorrect in the original Animal Crossing. More specifically, the Harvest Moon festivals for all of these years are wrong and occur up to a couple days too early or a couple days too late. Again, I mentioned that these dates are pre-calculated up to the year 2030, and simply fixing these dates to correspond to the correct ones will suffice as a solution. If you're a fan of Animal Crossing and you've been paying attention here, I'm sure a lot of you are quite sharp and are asking the same question I did. If the Harvest Moon Festival dates are pre-calculated to only go up so far, is this holiday the entire reason why the original Animal Crossing is capped to the year 2030? We are fairly confident the answer is yes, as the only logical reason Animal Crossing is limited from 2001 to 2030 is because of the lunisolar calendar system and the pre-calculated dates. Moving on, let's talk about some bugs and fixes for some of the unused or beta content in the game. First, if you visit the beta maps of the game through glitches or hacks, you'll eventually come across this weirdly textured gyroid or this glitchy rectangle. These are actually leftovers from Animal Crossing's time as a Nintendo 64 game, and the textures for these specific objects reference N64 draw functions. This is why, in Dobutsu no Mori on the N64, the debug gyroid here is actually properly textured. It turns out we can fix this on the GameCube by just updating the texture references to use the GameCube draw functions instead of the N64 ones. If we do so, we can save our gyroid friend from its glitchy mess, and also properly showcase this mural as a testing object for cycling through clothing designs. Now, how about we revisit our old friend the paper airplane one last time? As previously discussed, this paper airplane not only endlessly duplicates itself upon every map reload, resulting in a game crash, but it also softlocks the player when you pick it up and throw it. The reason why the paper airplane softlocks is because when you throw the plane, the game attempts to update your player state, and due to a bug, the game never returns control to the player properly. When you throw the airplane, you actually have some slight control over its flight trajectory with the control stick. To accomplish this, a function is called to cause your player character to ignore your inputs, or else you'd be moving both the plane and your player character at the same time. The issue is that this function never returns control back to the player when the plane lands. The function putting you in a refuse input state incorrectly clears certain priority values, and the player can never be broken from this state. This state is only used in two instances, when you're controlling the airplane and when you're controlling the NES games inside the emulator. The only reason you're able to regain player control when exiting the NES games is because doing so reinitializes absolutely everything, including the player. But the paper airplane does not have that luxury, and thus you are forever softlocked if you attempt to throw one. A potential workaround for this is to assign a different player state when throwing paper airplanes. For example, if we want, we can assign the axe chopping state to throwing the paper airplane. Now when we throw the plane, it somewhat looks like we're actually throwing it, and we can retain player control afterwards. The only thing is that assigning an arbitrary player state like this has unintended consequences. As it stands, so long as we have a paper airplane picked up, the game allows us to throw it at any time, no matter what. So even if we're talking to an NPC, we can throw the plane to enter a new state and regain player control. From here, we can simply walk away from any conversation, which heavily zooms out the camera to try and fit everyone in frame. We can also do a similar thing on Cappen's boat ride, where we can interrupt our sitting state, regain player control, and pause the game. From here, Cappen finishes his song, but since we're still technically in the boat ride, I guess the game gets confused and starts playing a KK song instead? This is not edited. I promise this actually occurs if you manage to pause during the boat ride and offset Cappen's song. So fixing all of these repercussions with the paper airplane would likely require introducing some special code to fix the refuse input states, or maybe just restrict throwing any planes while you're in certain states. Anyways, that's going to do it for me today. This video took a lot of effort to research and create, so I thoroughly hope you enjoyed it. Further, this video would also not have been possible without the efforts of Cuyler. I shout out Cuyler a lot, but for this video in particular, he was the direct source for the vast majority of these bugs, and he politely offered to explain and share his findings for this video. Continuing my appreciation, I'd also like to thank my Patreon and YouTube members for financially supporting this channel. Special shout out to my highest tier members Lunascape, Lorenzo, Cynthia, Mentis98, Silly Marina, Villager, Cass, Hornet, Tarumi, Benny Diddy, Pidge01, Kai D, ComfyBoy404, Japan Eat, Tammy's Head, Comfy, Exploding Bears, Holly Molly, Sitz, Idrin, Zip, Bobby Nard, and Clifford Longhead. And finally, thank you all for sticking around to the end and watching this video. Until next time.